So with this one, and again, make sure you pull out the whole point in the G there, and the GCF is greatest. So there are a number of common factors here. We want the biggest one. All right, anybody think they have the largest common factor? So what's the biggest number that goes into a 16 and a 100? Joe? Good, 4. So 2 would go into it, but 4 is bigger. So we want to use that 4. So what we basically do is divide each of those by a 4, and then that allows us to pull the 4 out. What we would have left over for this first term then would have had to have been a 4 and then the x squared. And then if I pull out a 4 from 100, that's going to leave us with 25. Okay? That doesn't necessarily mean you are done. You might be done, but that doesn't necessarily mean you just move along to the next problem. Because now what you want to identify is if it's a binomial, now we want to look to see, do we have a difference of squares? So we did have a greatest common factor. Now we want to look, do I still have a difference of squares? So if we go back to number 8, just understand what those phrases mean. A difference means you're subtracting. So far, so good. We are subtracting. And then is the 4, the x squared, and the 25, are those all perfect squares? Yes. That means we can go further with this problem. So the initial 4 is still there, but then now we know our little pattern for a difference of squares. So it's whatever we squared to get 4x squared. So that would have to be 2x. So those are going to be the first terms for both of those quantities. And then to square to get a 25 would have been a 5. So both of them end with a 5. And then one of them is a sum. One of those is a difference. All right. So in the homework you just got back, a lot of us are doing the GCF but not necessarily recognizing that we could go a little further with that. And that's okay. Okay, that's sort of the evolution we want to be able to take. The more we see, the better this is going to get. Okay, so this is our final answer for number 8. All right, now number 8, I listed 1, 2, 3. So this we would say is what's called a trinomial. So if you look at your trinomial options at the top of the paper, the first thing you're going to look for is a greatest common factor. It's the first thing we have listed in our options. So if we now look at these 3, do they all have at least one x? Good, because the one at the end does not. So they don't have an x. Is there a number other than 1 that would go into a 1, a 3, and a 2? No. So this case, there is no GCF. So just because we look for it doesn't necessarily mean there is one, but we definitely want to do that check real quick. So then the second option with a trinomial is our little product sum idea. This is where if you wanted to draw in your rectangle, that's where we did those rectangles. You could. And again, at that homework, by the time most of you got through that homework, there wasn't a whole lot of rectangles getting drawn anymore. We understood that to get the x squared, we would have had the x times the x. And then the only way that I could multiply to get a positive 2 and add up to be a positive 3 is if I had a positive 2 and a positive 1. All right. That's our product sum. These two numbers multiply to give you the 2. When we add those up, they give us a positive 3. That is your answer for number 9. Okay. Okay, let's do the next row, and then we're going to give you a little time to see if we could do these on our own. So try number 10 real quick. Okay. As you start to work on these on your own here in a little bit, look at your list. First, you're looking for a GCF. Every single problem on here, you're looking for a GCF. All right, Ella, was there a GCF? Good. There was no GCF. So we again look for it. That doesn't mean they always have one. In this case, we don't. So we don't have to worry about a GCF for that problem. It's a trinomial. So the only other way we know how to factor a trinomial is the whole little product sum idea. So the idea that we're trying to figure out, for sure, the x and the x will give us this x squared right here. But now these two numbers, we have to look for numbers here that would multiply to be a negative 20. So there's a few different combinations that will give you a negative 20. 1 and negative 20, 2 and 10s, 4s and 5s. So they need to multiply to be a negative 20, but add up to be the negative 1. That's your middle term. All right. Anybody got that? Assad, what do you got?
Negative 5, 4.
Good. Negative 5 and a positive 4. If I multiply those together, it's going to give me the negative 20. If I add those together, they would add up to be the negative 1x. All right, good. That's your answer. All right, 11. So we think about 11. Okay, to get it started here, Joel, was there a GCF?
Yeah.
Good. What was it?
3.
Good. So 3 does go into both of those. It obviously goes into itself. It went into 48 how many times, Joe?
16.
Good. So that becomes a 16x squared. And then when I did 3 divided by 3, don't think that this is gone now. There would have to still be a 1 right there. So when we pull out the 3, you have 16x squared minus a 1. So GCF-wise, we actually had one. We did that. That doesn't necessarily mean you were done. Or you might be done, but it doesn't necessarily mean we just go on to the next problem without looking further. Because now we need to identify if we have a difference of squares. Is this a difference? Is what's left over a difference? Yeah, for sure. We have that minus sign right there. That's what difference means. And then what we now have to identify is, are those two terms perfect squares? So is 16 a perfect square? Yeah. Is x squared a perfect square? Yeah. And is 1 a perfect square? Yeah. So we do, in fact, have a difference of squares. That one can get broken down further. The 3 that we pulled out at the beginning still comes down. And then now we do our little pattern for a difference of squares. Armando, what do you got?
4x minus 1, 4x plus 1.
Good. 4x minus 1, 4x plus 1. This is our simplified answer. We were able to do both of them in this problem. All right. Good. Okay, 12. So usually for 12. All right, Julia. Do we have a GCF, Julia? Good. So there is a GCF, so we are going to do that. She said it was a 2. All of those are divisible by a 2. So we're going to pull that out. Leaves us with x squared. What are we left over in the second term, Julia? Good. And then minus a what? Good. So that's okay. In terms of our GCF, we can definitely have one. We're going to pull that 2 out. Again, in the way we know, if you redistribute, we should get what we started with. Okay? So that's good. That, again, doesn't mean you're done. We still now want to identify, is there a combination? When we say product, that means they're going to multiply to be a negative 16. And then the sum is just saying they better add up to be a positive 8. Anybody find a combination that multiplies to be a negative 16 and add up to be a positive 8? Sad.
There is that.
Good. There is not. So you could do like a negative 1 and 16 would give you a negative 16, but that's going to add up to be negative 15. And if we flip the signs, you get a positive 15. You could try 2 and 8s. Those will give you a negative 16. But if you add those up, they're going to give you a negative 6. 4s and 4s will give you a negative 16. But if you add those up, they're going to get 0. That's it. Those are the only combinations that multiply to give you a 16. All right. So not every time we pull out GCF, you can continue on. In this case, this would be your final answer. All right. One more, though, before I turn you loose. Go to number 18. Try number 18. Actually, try 18 and 19. All right, 18. Tomas. Was there a GCF here, Tomas? What is it? Good. So all of those are divisible by a 3. So I'm going to pull that out. What would be left over? Good. 1x squared, then minus what? Good. And then what? Good. All right, the 1 is optional. If you want to put it in there, that's fine. I do like leaving it, but if you don't want it there, you don't need it. We did have a GCF that's a 3, but now we have a trinomial just like before. Now we're again going to look for numbers that multiply to give us a 6, but would have a sum of a negative 5. Did we find a combination for that one, Asad?
Negative 3 and negative.
Good. This one does have a combination that works. If I did a negative 2 and a negative 3, these guys multiply to give me the 6, and they're going to add up to be a negative 5. So we would have x minus 2, x minus a 3. That then is our final answer. So that time we were able to do both. All right. 19. See what you think about 19. Okay, 19. Omar's punching away there. Did you find a GCF, Omar? What's that? Good. There is no GCF, all right, other than a 1. So 4 doesn't go into 81. 2 doesn't go into 81. So there's 3 goes into 81, but 3 doesn't go into 4. So there's no common factor here. So then we still now need to check if there's a difference of squares. So do we have a difference? Do we have a difference? No, right? Difference means you're doing what? Subtracting. This is a plus. So it also means this is not a difference of squares. Those are the only 2 ways we can factor binomials. All right, at least right now that we would know. Since neither one of these is good, what do we write here? What? Prime. That's when you're going to write your prime, when you couldn't do any of the options that we have listed at the top of the paper. Okay? All right. The rest of this is homework. You're going to work on this now. Okay, we got plenty of time here. We want to kind of see where we are at, so we're not pulling out phones and shutting it down for the next 15 minutes. Get as much of this done as you can. This is not easy stuff. All right, there's a lot going on with these. If you have any questions, let us know. We'll be kind of walking around looking over your shoulder anyway, just kind of see how we're doing. But if there are some questions you have, use this time to ask those. And then this will be due tomorrow. Okay, we'll collect this tomorrow, see how we did. Okay. You're more